This is 7.4 continued. So we talked last time about how we could add or subtract vectors. We talked about multiplying a vector by constant, and we talked about finding the length of a vector or the magnitude of a vector. So today we're going to talk about something called a unit vector. So a unit vector is, so we usually denote it u with a little v. So the vector u sub v is a vector of length 1 unit in the same direction of vector v. And if we let v be equal to the vector a comma b, right? So the idea is, you might have someplace in space, right? Maybe you have this long vector here, and it's longer than 1 unit long, and so we can find a unit vector where the length of this vector here would just be 1, but it would be in the same direction as the original vector v. So this red one here is what would be the u sub v. And this is helpful again. So as we talked last time, a lot of the stuff that we're working on now is stuff that you would need to use in Calc 3. And so this is something that's helpful in Calc 3 because sometimes you just care about the direction of a vector. You don't actually care about how long the actual vector is. And if you can make the vector only be 1 unit long, then it makes it a little easier to work with. So that's where that's kind of coming from. So so the way that we find this unit vector is u sub v is equal to the vector v divided by the length of the vector v. So basically we take the vector and we divide it by its length. Dividing it by its length turns it into a vector of length 1. Now, when we say we divide it by its length, right, we didn't talk about dividing vectors. Really what we're saying is we're multiplying the vector v by the constant 1 over the length of v. So this is really what we're doing. And so in essence, it's really just a divided by the length of v, comma, b divided by the length of v. So it's actually a pretty straightforward process to do. So for example, find a unit vector in the direction of vector v being equal to 6i minus 15j. And you'll notice that here I didn't write the vector in component form. That's okay. We're allowed to go back and forth between ij form, component form. Some of the problems on Alex will tell you how they want the vector written. The other rule of thumb is if they don't tell you how they want the vector written, however they give it to you is how they want the answer. So in this case, since we were given the I and the j form, we want our answer to be in the I and the j form. So remember up here, I could have written this as a divided by the length of vi plus b divided by the length of vj. Right. So basically all we're doing is we need to find the length of v, and then we're going to divide 6 by the length of v and the minus 15 by the length of v. So from last class, right, the length of v, remember, is the square root of a squared plus b squared. So it's going to be the square root of 6 squared plus negative 15 squared. And that is the square root of 261. And you could leave your answer as the square root of 261. Sometimes things do cancel out, so you might want to kind of simplify that. So I'm actually going to break this down. Rather than the square root of 261, we're going to think of this as 3 square root of 29. 261 is actually 9 times 29. So I could split it up here into the 3 square root of 29. So then our unit vector, u sub v, is going to be our original vector. So we have the 6, and then we're going to divide it by 3 square root of 29i, plus we had minus 15 divided by 3 square root of 29j. And then in this case, I can divide 3 into 6, and I can divide 3 into negative 15. So it's really going to be 3 over the square root of 29i. And then I can just write it as minus 5 over the square root of 29j. Questions? No. It's fairly straightforward, right? Yeah, it's not too bad. Does anybody need me to wait before I go to the next page? No? Okay. So we'll try another one here. So B, find a unit vector in the direction of vector V being equal to 1 comma negative 5. So again, to find the unit vector, I have to find the length of my vector. So the length of vector V is going to be the square root of 1 squared plus negative 5 squared. So that's going to be the square root of 26, right? Because 1 squared is 1, square root of negative 5 squared is 25. So we have 26. I can't break down the square root of 26 at all, right? It is 2 times 13, so that neither one of those I can't factor out. So our vector u sub v is going to be 1 divided by the square root of 26, comma, negative 5 divided by the square root of 26. Questions? No? Okay. So that's the end of section 7.4. So the stuff we have to do in section 7.5. So 7.5 is the dot product. And so how the dot product works is the following. So if V, the vector V is A1 comma B1, or remember we can write that as A1I plus B1J, and the vector W is A2 comma B2, so A2I plus B2J. Then the dot product V dot W is defined by v dot w is equal to a1, a2 plus b1, b2. So, we cannot, so I talked about this last class, right? There is no way to take two vectors and multiply them together. You can take a vector and you can multiply it by a constant, which is what we did last time, or you can take a vector and you can do the dot product, but like when we took a vector and we multiplied it by a constant, our answer was a new vector, right? We basically took our vector and we made it longer or we made it shorter. The dot product actually gives us a number. So the dot product does not give us an answer that's a vector, it's an answer that's a number. So that's kind of an important thing to note. So note the dot product gives us a vector that is a number, or gives us, not a vector, gives us a value, or gives us as a, actually I should just, that's a terrible way to write it, gives us a result that is a number. Mathematicians, when we're talking about just a number, we actually sometimes give it a fancy word called a scalar. So i.e. a scalar. Okay, so when we do the dot product between two numbers, between two vectors, we're going to get a number. So, for example, find the following dot products given vector v is equal to 6, negative 7, and vector w is equal to negative 1, 4. So the first one we're going to find is vector v dotted with vector w. So basically, when you do the dot product, you're just taking the x components and multiplying them times each other, and then adding the y components multiplied times each other. So this is going to be 6 times negative 1 plus negative 7 times 4. And so that would be negative 6 minus 28, so negative 34. Questions about that? A lot of people like the vector stuff because it's easier than a lot of the other stuff we've been doing all semester. Right? There's a lot to kind of remember for it, but it is actually easier to do. Okay, so A is v dot w, B v dot v. So yeah, it is definitely easier than all the stuff before. So v dot v means you're dotting the vector with itself, right? So you can think of it, we're saying 6 comma negative 7 dotted with 6 comma negative 7, right? So again, we're just going to multiply the x components. So it's going to be 6 times 6 plus multiply the y components, negative 7 times negative 7. So you end up with 36 plus 49, which would give you 85. And we could do the same thing with w dot w, right? So again, we're going to multiply the x component times itself. So because -1 from the first w, -1 from the second w, plus 4 from the first w, 4 from the second w. So 1 plus 16, which is 17. Questions? No. Does anybody need me to wait before I go to the next page? No. Okay. So we'll do one more example. So we'll do this one with the i's and the j's, right? It's the same deal. So let's say vector v is equal to 3i minus 2j, and vector r is equal to -2i minus 7j. And let's find v dot r. And in these, it doesn't matter the order you write it, right? You could write v dot r or r dot v. You get the same answer, since we are just getting a number. So in this case, again, multiply the x components. So 3 times -2 plus multiply the y components. -2 times -7. So we're talking about -6 plus 14, which would be 8. And b, just to try another one, we'll try v dot v again. So it's going to be 3 times 3 plus -2 times -2. So 9 plus 4, which is 13. Questions? No? Okay. So there's one more thing from this section, and that is finding the angle between two vectors. So if you have one vector here, we'll call it v, and I have another vector here, we'll call w. We're interested in figuring out this angle between the two vectors, theta. So the way that we find that out is that the cosine of theta is actually equal to vector v dotted with vector w all over the length of v times the length of w. So for example, find the angle between vector v being equal to 12i minus 5j and vector w being equal to minus 3i minus 4j. So we're just going to plug in, right? To be able to plug in, I need to find some things first, right? I need to find v dot w. I also need to find the length of v, and I need to find the length of w. So I'm going to do each of those things separately first. So v dot w is going to be the x pieces, so 12 times -3 plus -5 times -4. So we have negative 36 plus 20, so negative 16. The length of V is going to be the square root of 12 squared plus negative 5 squared. And if you work that out, you get the square root of 169, which is 13. The length of W is going to be equal to the square root of negative 3 squared plus negative 4 squared. So that's going to be the square root of 25, or 5. So those are all my pieces. So questions on how I got any of those pieces? No? Okay, and then all I have to do is plug into our formula. So the cosine of theta is going to be, so V dot W is minus 16 divided by 13 times 5. So the cosine of theta is going to be negative 16 over 65. And then what am I going to do to figure out, what am I going to do to figure out theta? Yeah, find the inverse. So theta is going to be the inverse cosine of negative 16 over 65. And if you work out what that is, it's 104.3 degrees. Questions? No? You guys are very questionless today. I guess it's because it's a little more straightforward stuff. So yeah, is V times W equal to X? You mean the V dot W? Okay, so it's not equal to an X value or a Y value. It's just equal to a number. So it just gives us, it's basically something we can calculate from two vectors, and it's just a number. So it's not an X value or a Y value. It's just a number. It's just like, this is a characteristic. Kind of just like you can take the square root of a number and it gives you another number. It's kind of the same thing. Did I answer your question? Oh, yeah. So you can think of the cosine as X over R, but that's not, we think of that when we're dealing with stuff on the unit circle. 104.3 is not on the unit circle, right? It's on the unit circle, but it's not like one of the common values that we think of on the unit circle. So I'm not trying to think about this as really being X over R. I'm just thinking about this as I have some number and then I'm punching this in my calculator to get the inverse cosine. Does that help? I mean, you could theoretically think of it as an X over an R. It's just that doesn't get us anywhere in this problem. And as you go forward and you deal with vectors, we don't think about the dot product as being like an X. We just think about the dot product as it's just this number that is like something you can get from. I'm not using like adjacent over hypotenuse. Yes, the cosine, if I gave you what the angle is and you drew a triangle, then yes. So from a triangle, if you're dealing with a triangle, then yes, the cosine is the adjacent over the hypotenuse. Here there's not a triangle. So here we're just dealing with two vectors. So I don't have a triangle, so I can't really relate it to the adjacent and the hypotenuse. It's kind of like another way of saying, like, I'm giving you just some angle and I want the cosine of this angle. So if you were finding this part, you could think of this as as finding adjacent over hypotenuse, but these angles are not going to be nice angles. So they're not going to be angles that you can make a triangle from. So we're saying this is a relationship. The relationship between these two vectors and this angle is this right here. And then, yeah, it's always going to be a cosine of theta. And then, so I basically found these different values here. I plugged them in, and now I have this. I'm looking for some angle whose cosine is negative 16 over 65. And that's not a nice value, so you're going to have to plug it into a calculator. Does that help? Yeah, I just pulled the formula. I just wrote down the formula. I didn't show you where the formula came from. The formula technically comes from making a triangle and breaking down the vectors into components. And we just don't get into that in this class. So you will, if you have to go on and take calc, so here's the thing. If you have to go on and take calc 3, you will see this again, and they derive where the formula comes from in calc 3. If you don't have to go on and take calc 3, outside of the homework, you're not going to see this. Does that help? So I just stated this is the formula. No problem. Other questions? No. Okay. So then that's all I had to teach today.